next question, if the principal stresses and the maximum shearing stresses are of equal magnitude, numerical value is equal. Okay, forget about the negative or positive at a point in a stressed body, then the state of stress can be termed as. What is the meaning of that? It is written like a sigma 1 equal to sigma 2 equal to tau max. Okay, numerically, generally, numerically, then it will become how much? Something like a some value. Numerically it is becoming something like a 10 or something, you can say like that. Okay, so what is the condition it is possible? Generally the sigma 1 equal to sigma 2 will become sigma 1 equal to sigma 2. When it will become sigma 1 equal to sigma 2, then radius will become 0 generally. Okay, but if sigma 1 equal to minus sigma 2, then radius not equal to 0. What is the meaning of that? If sigma 1 sigma 2 a comma b is here, then sigma 1 equal to sigma 2 and radius is becoming 0. Instead of that, if circle is like this, in that case what is happening? This is the sigma 1 and this is the sigma 2, and here radius is not equal to 0, and here what is happening? Sigma 1 equal to minus sigma 2. Both are value same, but not numerically equal, but not in direction wise. Okay, this is the 0, and here if you observe, the radius is the same in all the direction. Even the maximum shear stress also becoming 0 here. Becoming equal. Shear maximum also becoming sigma 1. Let's say this is the R. Let's say this is the R and this is becoming R. Okay, so whenever the Mohr circle is like this, then in that case it will become like that. So when will this Mohr circle become like this? Okay, just now we have seen that is a simple shear or a pure shear. Okay, so let's take like for example here the point A is 0 comma tau. That means here sigma x equal to 0. And point B is 0 comma minus tau. That means here sigma y equal to 0. So you draw the coordinate system here. Okay, when only tau is there, no sigma x and no sigma y. So in that case, how to draw the coordinate system? Okay, A is 0 comma tau. If it is a positive in the downward direction, then this is the point A, and B is 0 comma minus tau, this is the point B. And if I draw the Mohr circle, then it would be like this. So here the circle, wherever it is touching on the normal axis, that will give the sigma 1 here, and then here on the side this is the sigma 2, and everywhere the radius is the same. So sigma 1 here numerically sigma 1 equal to sigma 2 equal to tau max. This is the tau max. Okay, so it will possible only in case of the pure shear. So let's look at the options. One is isometric, and then another one is uniaxial. When it is a uniaxial, how is the Mohr circle? Uniaxial. In case of the uniaxial, what is the A is a sigma comma 0, B is a 0 comma 0. So uniaxial is something. Point A is here, point B is here. So in that case, it will be like this. Okay, so what is the sigma? Sigma 1 is nothing but here sigma 1 is nothing but sigma, and sigma 2 is 0. Okay, and then if you take this radius is nothing but here tau max equal to R by 2 here, radius by 2. Sorry, R by 2 means R, which is a sigma by 2. Okay, uniaxial, in case of uniaxial, sigma 1 is only positive, sigma 2 is becoming 0 here. And what is the other one? Pure shear. So option is C here. And what is the another thing? Generalized plane state of stress. Okay, in the generalized plane state of stress, this type of diagram is not coming, but it will come something like this. Okay, some diagram something like this, or it will be something like that. Okay, it will come like that, but it won't come exactly like this. Okay, so option is C.